Hello everyone. Now we are going to see about auction system based on blockchain. The main goal of our project is to provide a system that enables users to create and participate in auction which is protected by tight security mechanism with greater emphasis on the blockchain technology and resulting product allows for the user to manage auction, make bids and validate results using their citizen cards for authentication and a command line interface to interact with the program. The basic structure of the program is as there are three main entities: an action manager, an action repository, and an auction client. The software was designed to support four main security features: bits, confidentiality security, and authentication bit, acceptance control, and confirmation bit. Author identify the anonymity and finally honesty assurance. The messaging system is composed of two main shells, multiple client interface through which users interact, and two servers which serve as redundant points for all clients to connect. All messages are in JSON format due to its user-friendly nature and protected with a hybrid encryption. Now let's see what are all the entities which are available here. Auction client, an application that interacts with the user, enabling them to create and participate in auction. Auction manager, a server that exposes a connection endpoint through which clients can exchange structured request response with it. The user communicates with the auction manager every time he chooses to create or close an auction. Auction repository, a server that exposes a connection endpoint through which clients can exchange structured requests or responses with it. The user communicates with the action repository every time he chooses to list auctions. All bids of an auction. List the user's bids of all auction. Find out the outcome of all auction and make a bid. This is the high level architecture diagram of the auction management system. What are the types? Auction types. English auction. The ascending price auction characterized for each bid only being valid if it overcomes the value of the previous one. The user with the latest bid will be considered the winner and the new bid receives the information about the current auction value before making his bid. Bid auction. The sealed first price auction characterized for no bidder. Knowing the current auction value, the user with the highest bid will be considered the winner and the new bid receives only the information about the auction minimum value before making his bid. Reversed auction, characterized for working in the opposite way of the English auction. By starting with the high value and each bid only being valid. If its value is lower than the value of the previous one, the user with the lowest bid by the end of the auction will be considered the winner, and the new bidder receives the information about the auction's maximum current and minimum value before making his bid. And now we are going to see about the security mechanisms. In security mechanism, first let's discuss about author identification. The first security mechanism lies on the side of the user. It is with the user authentication mechanism of the software, which ensures the existence of a real person on the client endpoint. The authentication is achieved by the connection between the system AC and the smart card reader. Connection to the user's host. Machine with a valid CC inserted. This is done with the help of the Python libraries. All users are identified by a unique username that is instinctively connected to the CC's public, crucial for the encryptions needed to communicate with the servers. The CC's private key is never seen by any entity. This characterization is assured by the smart card itself. Message protection. As any system made for end users must be, ours is deployed based on the assurance of security communication channels and complete integration of every message traded by all entities involved. Regarding the security mechanism linked with the messages passed through the sockets tunnels, we implemented a hybrid encryption approach. The encryption goes through two phases. The first one requires a symmetric key and the second an asymmetric key pair. All keys are generated using the Python library that ensures the security implementation of the cryptographic algorithm, which is AES, with mode OBF and RSA for asymmetric key pair. And and the diagram shows the message exchange between AC and the AM. Bit prediction of blockchain construction. Now let's discuss about it. The general idea of how bits are dealt with and stored is as follows. All bits are sent by the AC to the AR, which runs a scan to verify them and inserts them into the list reserved for the auction to which each belongs. Each auction therefore contains a list, and this list suffers from several operations that turn it into a fully encrypted and secure blockchain. And now let's discuss about how crypto puzzle deployment. Crypto puzzle are the important asset of the auction management system since they help regulating the rate of which bits are sent by each user. The main characteristics of a well implemented crypto puzzle is that it represents a challenge that requires a certain amount of time and effort to be solved. In our case, the crypto puzzle is simple compressed of a byte. The auction system. Now let's discuss about the dynamic code, bit validation and bit modification. Our auction management system supports two types of dynamic code, bit validation and bit modification, each delimited by a single function. User may assign these two functions or just one or none to an auction on creation by writing them in the AC's interface according to a specific format. The validation function will be executed every time by a bit is sent to the AR and validated by the program as the final step to completely validate the bid. This step is ignored if the validation function is empty. The auction creator may apply conditions inside the function such as preventing bidders from increasing the auction's current value in every low percentage, making calculations that may be of his interest. When a user makes a bid, he may choose to subscribe to the auction and define how much he is willing to pay. In this case, the modification function will be activated for him and a thread decided to the update of the bids will start. The modification function will be executed by this thread every time a bid is sent to the AR and completely validated by the server. If the new bid is not from the server, same user as the one linked to the thread. Now let's discuss about bit exposure and action validation. The bit exposure is the security mechanism that allows the system to prove to any user that no corruption take place during the auction by giving a bidder all that the server stores and the keys needed to decrypt and validate the content. Our auction management system makes available two sorts of bid exposure: the exposure of all information about a specific closed auction and exposure to all information about all bids made by the user that asks for it in the subsection. We will discuss them individually. Now let's see about bid reception. Reception are created by the AR when the system consolidates the user's bid. They are sent as responses to the users in the same secured communication channel between AR and AC. A receipt is a JSON object containing the serial number of the auction, the user and the bid amount and the evidence of the operation completion. It is important to mention that the way of communication channel is built is enough to ensure the receipt was created by the AR. However, we decided to include a signature inside the receipt as an extra security measure and a more direct proof for the user that reads the receipt. This signature is basically the name of the bid owner signed by the AR. And let me say the minimum requirements, and we need a Linux system or Linux virtual machine to run this, and we need the Python, which should be of version above 3.9, and here we have used a few Python libraries, and we have installed Docker platform, and we have run everything inside the Docker platform, smart card reader, and up to date citizen card. These are the minimum requirements. Thank you for watching this video.